Okay, children, welcome back to Metallurgy class. It is our fifth class. In our previous classes, we have been discussing about the various stages in extraction of the metals, and after obtaining the metals, different types of purification of the metals. All we have learned in our previous classes. Today, in our fifth class, I am Gurumurthy, going to present you the final process of refinement of the metals and corrosion. So all those things we are going to learn in today's class. So hope you will enjoy my lesson, enjoy the lesson metallurgy. So pay attention, children. And let us see once again what topics are going to be covered in this session. The refinement of crude metals. The one more is left after our previous class, that is electrolytic, refinement, and of course the corrosion, important phenomenon, and the preventive methods of corrosion. How can we prevent the corrosion? So this is what we are going to cover in today's class. So on behalf of you and me, I extend my sincere thanks to our DU sir and both the secretaries of DCED Suryapet and Kamam. Before going to today's class, let us recall what we have learned in our previous classes. I just try to recall the things that we have learned in our previous classes, various stages, various steps involved in extraction of the metals. Concentration is the first step, then extraction, that is reduction. Last step is refinement or purification of the metal. This is the chart. Let us see where we are actually. So this one we have finished. This one also we have finished. Here we are here. In the refinement category, we have to learn about the electrolytic refining. This is what we have learned in previous classes. Low reactive metals, how can they be reduced to the metals? Let us have a quick look. The purification. So distillation, falling, liquefaction, all are finished. In this class, we are going to learn about the electrolysis method. So what type of metals are purified in this electrolysis method, and how the impurities are removed, and how can we get the 100% pure metal. See, we have finished distillation, of course. After that, we learned about calling and what type of metals are purified in this method. After that, yes, in our previous class, liquefaction also we have covered. Lead and tin like metals are purified by liquefaction method. This is what about the liquefaction. Now, let us come to today's class, that is electrolytic refining. What is it and what type of metals are purified in this method? Once again, electrolytic refinement. This method, electrolytic refinement, involves electrolysis. You know about electrolysis. In your previous classes, you have learned about the electrolysis method by passing current through electrolyte. The electrolyte is disassociated into its components. Two electrodes, one is cathode and one is anode, connected to negative and positive poles respectively. In this process, electrolytic refining, the impure metal is made to act as an anode, and same metal in its pure form is as cathode. So this is what about the two electrodes that we are going to use in this electrolytic refinement. The impure metal is used as an anode, whereas the pure metal of that impure metal is used as a cathode. And the electrolyte that is going to be used for this electrolysis method is the aqueous solution of the metal is used as electrolyte. That is a soluble salt of the same metal is to be taken as the electrolyte. So what happens? Let us see here. The M refers. This M refers to the crude metal, that is impure metal. At anode, it undergoes oxidation reaction, that is loses electrons at anode. At cathode, it reaches cathode as it is positively charged. The cathode attacks it. There, it gains electrons by means of reduction, oxidation. It converted into pure form of the metal. This is what in brief about the electrolytic refinement. Here, from impure metal to the pure metal. Now let us see the picture that depicts the experiment, that is electrolytic refinement. The copper-like metals are refined in this method. The impure copper, also known as a blister copper, is taken as anode. Here you see, this is anode. This anode is nothing but the impure copper, blister copper. It is connected to the positive terminal of the battery. Whereas this is the pure form of the copper. The pure copper plate is taken as a cathode, that is connected to the negative terminal of the battery. So these two are about the electrodes used in this electrolysis process. And you see the blue colored aqueous solution is an electrolyte. Here it is copper sulfate aqueous solution. It is taken as electrolyte for this electrolysis method. Then what happens here? The impure copper loses electrons and becomes as a copper ions by losing 2 electrons. At anode becomes copper plus 2 ions. If copper plus 2 ions are released into the electrolyte, then the cathode attracts them towards its that is a pure copper. Then here what happens? The copper ions gains the electrons from the cathode and reduces to the fine copper, that is refined copper or pure copper. So impure copper released into electrolyte in the form of ions, copper ions, and then in the pure form it is deposited on the cathode. So in this way, the copper, blister copper, is purified or refined into a pure copper, that is in the form of a deposit on the cathode. But the condition is that the electrolyte must be an aqueous solution of the copper. As we are refining copper, we have to take the copper aqueous solution, the salt solution. You see the soluble impurities. But then what about the impurities in the blister copper? The soluble impurities go into the electrolyte, whereas the insoluble impurities from the blister copper, they get deposited at the bottom of the anode. Here they deposited like antimony, selenium, tellurium, silver, and gold, and platinum. They are all precious metals. But the problem is we cannot recover them as the cost of the refining may very high amount. That is why it is better to uh, leave them as a form of mud, and we cannot use them for good purpose. This is all about the refinement of the copper. Now let us move on to our next one. That is, in this method, zinc also can be refined. But here the condition is that the impure form of zinc made to anode, and a pure form of zinc is used as cathode, whereas the salt solution, aqueous solution of the zinc, like zinc chloride or zinc sulfate, may be used as the electrolyte. That is the condition. Now let us see. Students, watch the video carefully. Check, check.
సౌండ్ రావట్లేదు దీన్ని సౌండ్ రావట్లేదు
అవునా
సౌండ్ తక్కువ పెట్టినాను
So watch the experiment carefully. Students, you will get to know easily. That is here. Okay, students, you hope you might have enjoyed the video and you have understood about the electrolytic refinement in a funny way. I know you like the videos with a lot of wit. That is why I use this video. Now let us step on to the second topic, that is corrosion. The word you might have heard in your day-to-day life. Okay, students, I'm going to bring some pictures on the screen. Observe them carefully. Here you are asked to guess what the phenomenon be called as. Let us see some more examples, some more pictures. Yes, you can see a plate, the metal copper one. It is a wall used in the used in our domestic purpose. It is a plate, silver plate. So see the difference how it is. Actually, it is a pure one, but it is somewhat spoiled. A spanner is there. Is a motor spare part. All the articles are commonly seen in our day-to-day life. Can you expect what are those? See, the metals like iron, copper, silver, and aluminum. The surface of those metals, when they are exposed to the water, air, moist, they form a layer on them with a different color like a brownish or a greenish layer. This layer is known as a rust, and this process is known as a corrosion. Of course, there is a slight difference between rusting and corrosion. So what happens? We often see that the surface of metals becomes either dull or slowly eaten up when they are kept in open for a long period of the time. When we keep a sparrow or a spanner or a nail in an open place for a week or like thing, then after 1 week of time, when we come back to recover it, the shape of the nail is changed. The color of the nail also is changed. We can observe a layer is formed, a brownish, reddish brown color. A layer is formed on it. This is we call it as తుప్పు అంటాము. చాలా వర్క్ మెటల్స్ అన్ని కూడా తుప్పు పట్టిపోతూ ఉంటాయి, మనం చూస్తూనే ఉంటాం. As you know, children, without metals, the life of humankind will be in misery, as I told you earlier. But we have to preserve them against the corrosion or the rusting. Yes, the process of rusting is known as becoming rust or get rusted is known as rusting or corrosion. What happens? What kind of changes can we observe when the metals get rusted or get corroded? The first thing is that a colored layer is formed on the surface of the metals. Based on the nature of the metal, the color may be different. Metal surfaces are eaten up or destructed. The lustrous nature is diminished and the metals are faded. Moreover, the quality of the metal is degraded. That is the main loss. For example, iron metals on rusting, a brownish layer is formed on them in the presence of air and moist. See, as long as you keep the iron material in away from the air and moist combination, then they won't get rusted. So this is the condition. This is the required condition for a metal like iron to be rusted is air and moist. Without air and moist, they cannot get rusted. They do not get rust. The copper. Copper also get rusted or corroded. A greenish layer is formed on them. We have seen in our pictures earlier. Moist air and carbon dioxide in the atmosphere are required to get copper rusted. Of course, girl children, particularly, you wear anklet chains. పట్టీలు వాడుతుంటారు కదమ్మా. When they buy them, they are lustrous and very bright one. After using them for 2 or 3 months, they become blackish because of the moist. They are exposed to the atmosphere. They react with moist air. That is, moist means the water percentage in the air, and H2S, hydrogen sulfate. A blackish layer is formed on the silver material. Like aluminum also rusted. Because of this rusting process, one minute. Let us see a video which depicts about the rusting process. Okay, students, we are going to watch an activity which is given in your textbook. What are the conditions for a metal like iron nails get rusted? Now let us investigate the conditions under which the iron is rusted. This is what we are going to watch. So watch the video carefully. Yes, in test tube A, we have taken nails and poured the water up to some height so that the nails are dipped in water up to half and they are half of the nail is opened. A cork is closed here in B. The nails are completely immersed in water and oil also poured on the bottom, on the top of the test tube. This is the test tube B, and this is the test tube C, where no water is available, and also if there exists a moist water in the form of moist, that also be taken out by the anhydrous calcium chloride. It absorbs the moisture in the test tube. So only air is present. Here only water is present, but here moist, that is water, and air also present. What happens? Let us see. After a few days, yes, the iron nails in the test tube A, they rusted. But whereas in test tube B and a test tube C, the nails are unrusted because the nails are under the suitable conditions where the ice and the water are present to become rusted or they become corroded. Whereas in B and C, the nails, in this B, for example, in this B, only the water, only the moist is present, whereas the air is not present. Actually, the corrosion is nothing but the process of oxidation. So oxide is required. The oxide in the air is combines with the iron, forms the iron oxide. Okay, that's all about we are going to learn in our next class. Here, only the water is present, no oxygen is present, so these nails cannot get corroded or oxidized. In this, oxygen is present, but not the moisture, but not the water. Now you can understand what are the conditions to become the iron nails corroded. So what are those? In the presence of air, that is in the presence of oxygen in the air and the water, then only they get rusted. Otherwise, the iron will not get rusted. Yes, this is what I told you. What are the conditions required under which the iron gets rusted? That is only in the presence of air and water, the iron gets rusted. One more video is there for you for our better understanding. Let us see it also. The same experiment is repeated here because this activity based questions are appeared in your previous examination papers. That is why it is very, very important. Maybe asked as the material required to perform the activity, or you may be asked to explain the activity. One more video is there. Different articles made of different metals like silver. A spanner is made of iron. A coin is made of copper. The layer that formed on the metal is different. For iron, as we call it as rusting, forms oxide layer, iron oxide layer, whereas copper, it is copper carbonate. For silver, it is silver sulfide. Okay, children, as the time is up, we have our next class. I'm going to wind up the class now, and we will continue the class in our next session. Hope you have enjoyed my class today, and try to revise them through your textbook reading. Okay, children. Bye for now.